Welcome, welcome. This is VCE Methods 2020 Exam 1. So the first question is always going to be like a product rule / chain rule question. Very easy. Everyone knows how the product rule is derivative of one times the other, and then you switch it around and add them together. Very simple question. For question 2, there's 2 marks. So you want to first find the derivative and then sub in 1 into the derivative. You don't want to do it both in one step. Alright, this question I recommend making a probability table. Just subbing in all the knowns, and then it'll be clear what you need to solve for to find an unknown. I always recommend using a probability table for these type of questions. It makes life much easier. Alright, so now there's just going to be a lot of simplification. So we're going to make sure we have the same denominators by multiplying the numerators. And we're going to add things together, and then we're going to cancel things out. And then just simplify things down at the end so you get m in terms of n as the question asks. So for these trig graph questions, I like to imagine the trig graph as a circle, where at the origin we start at theta equals 0, and if we move in the positive x direction on the trig graph, we're going anti-clockwise around the circle. And if we move in the negative x direction on the trig graph, we're going clockwise around the circle. Since the tan graph is bound by those two asymptotes there, we know it's all within one period. So if we move clockwise or anti-clockwise, it all has to be within the first quadrant or the fourth quadrant. So we know it's going to be less than pi on 2 and greater than negative pi on 2. And we also know that y1 equals root 3, and we also know that y negative 1 equals negative 1 because of the 2 points we're given there. So now we can set up simultaneous equations where we have two unknowns, a and b, and we have two equations. And then we use inverse tan to find the angle given by the side lengths root 3 and 1. And then we have the side lengths negative 1 and 1, because we know that root 3 is actually root 3 on 1. And now you can use magic triangles here, as in the 60 degree, 30 degree triangles that we already know, or we can just remember it from heart. For example, we know that tan gives opposite over adjacent. The opposite angle here, the opposite side length here is root 3. The adjacent one's 1. We know that pi on 3 is bigger than pi on 6. That gives a bigger angle. Therefore, it's going to be pi on 3. And we know this next angle is going to be negative, because if we're going left of the origin, that means we're going clockwise around the circle. Therefore, it's going to be, and we know that tan is negative in the fourth quadrant. Therefore, it's going to be negative pi on 4, because we know that with side lengths of 1 and 1, that gives us pi on 4. So it's going to be negative pi on 4. And now we just solve for what a and b are by setting up elimination. And here I'm going to minus the bottom from the top, since that gives us pi on 3 plus pi on 4, which is a bit easier to solve. And then we make the denominators the same, so 12, and the numerators become 3 pi and 4 pi, which is 7 pi on 12, and then we divide both sides by 2, so we get, that multiplies the denominator 12 by 2, so we get 7 pi on 24, b equals 7 pi on 24. And now we have the two equations, a plus b equals pi on 3 and negative a plus b equals negative pi on 4, where we can sub b equals 7 pi on 24 into to find what a is. Here we subbed it into the top one. And then we want the same denominator, and then we solve. And we get pi on 24. And then we check that it's in the bounds that given at the top, which it is. So in this question we have two logs. We have x plus 5 as the middle term one log, and x plus 9 as middle term another log. And we know that we can't have log for negative number, so the inside of both of these logs have to be greater than 0 for the whole it to exist. And so negative 7 doesn't satisfy the left inequality, because we know that negative 7 plus 5 is less than 0. So we have to reject negative 7 as a solution. Therefore, x equals negative 1 is the only correct solution. Here we have to first make sure we actually define what x is, because a lot of people like using x, including me. So you have to first define that x is a binomial variable. The sample space is 4, the probability of success is 3 out of 5, or 3/5. And since the sample space is 4, the probability that x is greater than 3, greater than or equal to 3, is 3 or 4. So it's probability x equals 3 plus probability x equals 4. Here we have 4 choose to, and I know we did it in the previous question, but if you can't really remember how many combinations there are, where you have 4 choose to, there's different ways to work it out. So this first way, you can imagine there are 4 slots. You can fill in 2 slots at a time. And then how many combinations are there? Unique combinations can you fill in so there are 2 slots filled up? Or you can do this triangle method, and you tier them. So you go 0 to 3 to 4. Make sure you remember the 0. And then you imagine it as 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. So 4 choose 2 gives you 6. And so those are 2 methods where if you're stuck and you can't remember during the test, then that helps. So for these coming questions, all you have to really know is that x values become y values and y values become the x values when we go from the original graph to the inverse graph. And you also have to know that the inverse graph is going to be a reflected version of the original graph across the line y equals x. So a diagonal line that runs up through the page, it'll be reflected across that. Also know you have to draw your curves smooth and continuous. You can't draw jagged lines even if that helps you keep on track, because that'll be marked incorrect. You also have to know that when they cross the inverse in the original graph, the area above and below the line y equals x will be the same area, since there's symmetry about the line y equals x. Therefore, you can multiply the area, one of those areas, by 2 to get the full area. And here we have y equals 2x squared as the top curve, and that's easier to integrate than square root of x on square root of 2. So we're going to find x minus 2x squared, and we're going to use that, we're going to integrate that and multiply that by 2 to find region 1. Because of the form they want your answer in, we know that there has to be a square root at the top. And so we know we want to simplify it early to get the square root to the top. And so we're going to rearrange this, becomes root 2 on 3. And we want to do this early, because otherwise if we do it too late, it won't work. So this new question is telling us that the slope of the line we found in BI is the tangent that we found in II. So it's telling us to set these equal to each other basically. And since you found two versions of slopes, it should be going off in your brain that you should be setting them equal to each other. So there are two tangents of f that could go through the point P, but we're going to use the one we originally started with, which is a equals 4. And we know that the derivative of f with respect to a is 2a plus 3, so f dash of a equals 11. And then we have the point P, which it passes through, which has x value of 0 and a y value of 1. No, sorry, it has an x value of 1 and a y value of 0. So then we sub all of those in to find what c of y equals mx plus c is. And we have c equals negative 11. So we get y equals 11x minus 11. So what I'm showing here is that the minimum distance will be given if you translate it so that the minimum value, the minimum turning point of f of x is directly above the point P. And so you have to find out what the x coordinate of the minimum is. So for this question, we want x log e to the x by itself, but we only have 2x log e to the x plus x. So we minus x, and then we divide both sides by 2 to get rid of it from the left-hand side of the equation. And then half is a constant, so it doesn't have to be under the integral. And then we integrate both sides. And then that gives you the antiderivative of x log e to the x. as a note, log e to the 1 here equals 0. So the whole term becomes 0. At the point where y of x and g of x are tangent, they you could set y of x equal to g of x, but then there are too many unknowns, you can't solve it. But we also know that the derivative or the slope of g of x at the tangent is the same as the slope / the derivative of y of x at the point they touch / the tangent. So we can solve the derivative of g of x equals the derivative of y of x here, and that gets rid of the k, because the k has no x value associated with it. So then the k just falls out, so then the derivative of g of x is just the derivative of f of x. And here we can't just sub in x equals e into g of x to find out what g of x is equal to, because there's k. And we know that k is what's making y equals 2x tangent to f of x. Sorry, tangent to g of x. So we know that they will have the same points at that coordinate. So we can sub x equals e into y, so y of e, and that'll give us the y coordinate for both g and for y. So we can use that to find the y coordinate of g. So now g of e equals 2e. Alright, to see what happens to g of x as k increases or decreases, we'll first sketch f of x and its inverse. And we'll see that by moving f of x up, due to it having to be symmetrical about the point y equals x, that moves f inverse of x down. Right, so we can see as k increases, it moves. If k is a really big number, then they won't intersect at all. Right? So we need to find the k value for when they do intersect, and then we know that k has to be greater than that value for them not to intersect. So what we could do if we had a calculator is we could find g and g inverse of x and then solve them equal to each other to find what the k value is. But that's way too complicated to do by hand. So what we're going to have to do is what we did before, right? We know that g of x and y equals x, when they intersect, they're going to have the same, when they touch, they're going to have the same tangent, because y equals x will be tangent to g of x. So they're going to have the same derivative. So we set the derivative of g of x equal to the derivative of y equals x, of y of x. And we know the derivative of y equals x is the derivative of x, which is equal to 1. We know the derivative of g of x equals log e of x plus 1, which we found before. because the k falls out because it doesn't have an x associated with it. So this is really easy to solve, and we get x equals e to the 0. So now we know what x equal to. We do exactly what we did before. We can't sub x equals 1 into g, so we have to sub x equals 1 into y. And then if x equals 1, y equals 1. So we have a y value of 1, we have an x value of 1, and now we just solve for k. So that brings us to the end of the exam now. We're pretty much done. Knowing the properties of like inverse graphs and how they relate to the original graphs is a very common question for the later stages of exams, so both exam 1 and exam 2, for visualizing how they move, how they work, the relationship between the original and the inverse. So that's very important to get good at and to practice visualizing in your head. A lot of the exam was algebra. It was algebra, simplifying, log laws. All in all though, I don't think this exam was too difficult, and I think the future exams beyond, like in 2022 and beyond, will be much more difficult than this. So make sure you get a very wide, like you do a lot of exams, because there'll be a harder exam than this in the future. So just make sure you keep practicing, keep working at it, don't get stressed out, and you'll do great. Good luck.